What's going on, everybody? We're now going to be doing the name to structure stereoisomer examples. So I've got my trusty carbon with my green, purple, blue, and red. I've got my pens, but this time more than ever, you are really going to want to make sure that you've got a pencil because you don't know necessarily which direction you're going to need to be drawing these components here, the R or the S's. Because remember, you are going to need to be including dashes and wedges in some of these. So make sure you're drawing your shapes with those, so that way if you go back, you can erase it easily without having to go and redraw the whole structure, or just commit to redrawing the whole structure if you like pens. Either one of those is fine, but really recommend pencils for this. Okay, our first one we're gonna do is we're gonna do R 2, 6 dimethyl octan 6 all. Okay. So let's go ahead and look, and we're gonna start filling this out exactly the same way as we would have done earlier, where we're gonna take it piece by piece. We're only gonna care about this at the very, very end of our structure. So I have oct. Oct is 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 carbon chain. On position 2, I'm going to put a methyl. 1, 2, 3, 4, 5, 6. I'm going to put a methyl, and I'm also going to put an alcohol. So that's 2, 6 dimethyl, octan, 6 all. And again, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, it tells us R, but it doesn't tell us a number. So we need to be able to identify by ourselves what number of this carbon or which of these carbons is chiral. So this one here is attached to a chain, a hydrogen, and then a methyl, and then this would also be a methyl group as far as this carbon is concerned. It's just a single carbon attached to it with 3 hydrogens. So this one's not actually going to be our stereocenter. This carbon, this bad boy right here, is going to be the one that we're going to be using. So now what we need to do is we need to identify which of these is going to be our priorities. So let's go ahead and get this set up. I've got my empty molecule here. Lowest priority, well, there's no hydrogen this time, so it's going to have to just be this single carbon chain. The single carbon chain is going to be the lowest. Then I've got, okay, this is a 2 carbon chain. This is a long carbon chain. So my next lowest will need to be this 2 carbon chain. Then my next lowest will need to be this long carbon chain. And finally, my alcohol is going to be my highest priority. So I got purple on my alcohol, blue on this one, red on this one, green on this one. So let's go ahead, and I'm going to start by making my blue and my red because I know those positions. So it's going to be blue here, and it's going to be red here. Now, this is where this is probably one of the hardest types of problems that you could have to do. Some of you may get this right away without having to worry about it, and if you do, great, awesome, congratulations. But those of you that struggle, do not feel bad. I mentioned before, this is the wall chapter. This is the chapter where, at least naming-wise, like, students will hit a wall in organic chemistry. It doesn't help that it's also usually accompanied by concepts that are a lot harder. So do not feel bad if this is starting to feel like it's a lot, and they're having some struggles with this. So don't feel bad. So what we're going to have to do is I've got my blue and I've got my red. We need to predict. We're trying to get an R configuration. So let's try it out. Let's try putting my green. We'll put my green here. And we'll put my purple here. So we have to pretend, or we have to test which of these positions would give me an R configuration. So if I do it this way, if I were to put my methyl group going back and my alcohol group coming forward, I would have a 1, 2, 3. I would have an S configuration, and that would not be okay. So I need to instead flip the positions of my green and my purple. So if I flip their positions, I've got, put it like this, 1, 2, 3. that would be an R configuration. Now, again, don't just assume, okay, well, it's an R configuration, so purple comes out, because that's what I'm seeing here. You have to reorient based on what you have in the picture here. So I'm going to have to re-put my blue going that way, my red going that way, which means my green is going to actually be coming out of the page, and then my OH with my crappy eraser, because I left my good pencils at school, let's erase that OH as well. Will look like that. Now that looks awful. I'm not going to lie to you. That looks awful. You could also just leave this blank and not draw them until after you've tested this. Or I mentioned if you had like pens, you're just going to have to redraw it. Honestly, I just usually redrew it. So I would do that, and then I would kind of do an actual equals this 1, 2, 3, 4, 5. Get my wedge going on. Get my dash going on. And then as long as you circle that, you are good. You've got all the information. So I'm going to show you how to do this without having to erase it, where we're going to test it before we draw it on the next one. But this would be our structure, 2,6-dimethyl octan 6-all. Okay, our next example, I'm going to redraw it down here. We've got parentheses, 2s, comma, 4s, close parentheses, 4 methyl hex and 2 amine. Okay. Now we're going to go, we've got a hex. So we've got 1, 2, 3, 4, 5, 6. We've got a 6-carbon chain. We know that our stereocenters are going to be here. What's 1, 2? And 1, 2, 3, 4. So let's go ahead and think about what would be on stereocenter number 2. So on position 2, I have an amine, and I'm going to have a hydrogen. So I'm going to now, what I'm going to do is I'm going to very lightly draw in a hydrogen and an NH2. And now let's think about what each one of these would have. So I'm going to do a green dot up here next to my H, because it's got to be my lowest priority. Nitrogen has a higher atomic number than either of these carbons, so our amine is going to be a higher priority there. So I've got green and purple. And then this is a long chain, and then this is a single chain. So I've got my dot there, and I've got my dot there. So same thing as before. I've got my red over here, I've got my blue over here. Let's just test it out. So if I put purple here, and if I put green back here, this would be an R configuration, so I need to flip them. And technically you can pick any two of these and swap them and it will change the configuration, but I like swapping these two. So now if I swap these two, I have an S configuration. Now I need to get this to match up with what I'm seeing there, so I'm going to flip this around. I've got red going down to the left. Sorry about that. I've got red going down to the left. I'll do it this way. Red going down to the left, blue going down to the right. So I need green to be coming out. So now I'm going to go back and I'm actually going to block in my H. And I've got purple that's got to be going back. Okay, that looks a lot better. It's hard to tell because it's got a little smudged right there because I moved my finger across it. But this would be the dashes, and that would be the NH2. And then on position 1, 2, 3, 4, we're going to have a hydrogen. And you wouldn't actually need to draw this either because this one's a hydrogen. You could go ahead and erase that if you wanted to. So I'll show you how I would probably redraw this because I'm kind of a perfectionist. I would accept this, but I'll show you what it would probably actually look like. So now we're going to go ahead and we're going to draw a hydrogen, and we're going to draw a methyl. So it's just going to be a line. Hydrogen has to be the lowest priority. This is going to be actually blue again because this is the longer chain. This one's going to be red again because it's a shorter chain. And then our, this one's going to be purple. This one's going to be blue. And then our red is actually going to be our methyl that we added back here. It's important that you don't get these things mixed up. You'll notice I usually do the lines here, like I did up here, where I actually draw the lines really close to the stereocenter. This is the problem if you don't draw the lines over the stereocenter. You have to make sure you remember that this side is the purple on this one, that you don't use the blue there. Okay, so I've got purple, I've got blue. Let's just test based on this configuration. This would be an S configuration. It's the same that we had it before. So now I just need to get it to match up. I've got purple, I've got blue. So I need my methyl to be coming forward. I need that to be coming forward. I'll need my hydrogen to be going back. Now again, that's like a mess, so I would probably get in the habit of redrawing these. I would do kind of a rough sketch to make sure you understand what everything is and make sure you've got it all in the right position. But then from there, so it's 1, 2, 3, 4, 5, 6. I don't need to draw these hydrogens in, so instead I'm going to draw this going straight up. And I'm going to draw this one going straight up as well. And this got a little smudged right there. But 1, 2, 3, 4, 5, 6 on position 2, there is an amine. On position 4, there is a methyl, both of which are stereocenters and both of which have an S. So notice the most important thing on this one, and this is another area where people tend to get confused. They're both S just because this one went into the page and this one's at the top of a peak, in quotes. It's at an up thing. Does not mean that this one's also going to be back, because the situation changes depending on the location on the chain. And this one, the left side of the chain was the second lowest priority, and this one, the second left side of the chain, was the highest priority. So it changes the 3D configuration of this shape. It's going to change how it's going to look. And so just because this one was back into the page does not mean another S later on in the same type of position will be going into the page as well. You have to assess each of them individually. I know it's frustrating, I know it's annoying, but you have to do that, otherwise you do not have a guarantee that you're going to get things done correctly. So this will be my answer. Again, circle this. This can be your kind of rough sketch. This can be your one that you've got your actual information for. So those are my 2 examples for name to structure. Name to structure is definitely harder this chapter than structure to name. If you've got any questions, please let me know. Shoot me an email so I can try to figure out a way to help you out. In the meantime, this is Mr. Diamond, signing off. And yawning. Apologize. And yawning. Have a good rest of your day, everybody.